Hey everyone, this is notes number 16. Okay, separable differential equations. Make sure that you guys write that down. Here's our FLT. Jot this down as well. And then press play whenever you're ready. Okay, so in the last lesson, let me just show you real quick. You had a you were given, I guess not in the last lesson, but all the way back in first semester when you were given an implicit equation, you were able to find the differential equation there. Okay? And then you learned that, well, really, we're just learning the reverse process. So how do we go from the differential equation back to the original equation there? Okay? So slope fields was a graphical way of kind of figuring out what the graph looks like based on the slopes or the field of slopes. So today it's more of the analytical approach, okay? And this will be number 6, FRQ number 6 on your AP exam, and we'll go into depth with that when we get into the AP prep, okay? But basically, you're focusing specifically on differential equations that are separable. And I'll tell you what that means, but not all differential equations are separable. So you're focusing on a certain type of differential equation, okay? So when you're given a separable differential equation, along with some type of initial condition, you're going to be able to solve the differential equation. And what I want you guys to understand here is when they ask you to solve the differential equation, they tend to use that phrasing, but on the AP exam, they also might switch it up to this phrasing right here, find the particular solution. Know that that means the same thing. Okay, finding the particular solution and solving the differential equation is really the same thing. Okay, so here we go. I'm actually going to do 3 problems at once so that you can kind of see the patterns here, okay? Make sure that you give yourself enough space. And we're actually going to work this out vertically here. So just to show you, whenever you're ready, press play. But just to show you, you will be provided a differential equation, right? And they'll give you some type of condition, which is a point. And that's really all you need. All right? Okay, so I'm going to go over the 3, but really 4 main steps. Okay? So here are the 4 steps. And with practice, this is your guaranteed points on your AP exam, okay? So first step is to separate. Okay? Next step is to integrate. Third step, not really, find C. And then fourth step is to isolate. Okay, separate, integrate, find C, isolate. And that'll click a lot more once we actually do all of these problems here, okay? So here we go. We're going to first separate the variables. So we're going to leave variables on the left-hand side and the variables on the right-hand side here, okay? So I'll go through the first example. Okay. Now, sometimes they might write y prime. I encourage you to change it to dy dx, okay? It's actually required. Okay, first thing you want to do is you want to pay attention to what's at the top here. So in this case, it's dy. So that means you want all of your y's on the left and everything else on the right. Okay, so whatever is on the top, you're going to keep on the left here. So here, y is going to be on the left. Over here, g will stay at the left. And then over here, s will stay at the left. Okay? So here we go. What you do is you want to make sure that all of your y's are on the left-hand side. So notice how we have a y on the right here. It's x times y. So mathematically, I would have to divide by a y on both sides. Okay? So at the same time, if the y's are on the left, that means the x's have to be on the right. So this dx down here, since it's divided by dx, I'm actually going to multiply by a dx here. I'm going to multiply by a dx here. What happens is the dx over dx cancels out along with the y divided by the y. Make sure that you guys are moving it mathematically, okay? Don't just pick it up and throw it to the other side. Because sometimes people forget or do it incorrectly in terms of the movement. So what we have here is we have 1 over y dy on the left. And on the right side, we have x dx on the right. Notice how we separated the variables. All of the y's are on the left, all of the x's are on the right. Okay? So let's do another one here. Here's the second example. So again, we're going to keep the g since it's on the top. It says dg is on the top. We're going to keep on the left. So that means this divided by g on the right side. We're going to have to multiply by g to move it over. Okay, so that means the dt needs to move over. So I'm going to multiply by a dt, multiply by a dt. That causes dt's to cancel out. This causes the g's to cancel out on the right. So then you're left with g dg equals t dt. Notice how the g's are on the left, the t's are on the right. Okay, so pause this one here, pause the video here, and try this one on your own. And then press play whenever you're ready. Okay, so since ds is at the top, we're going to keep it at the left. The s's will be on the left, the t's will be on the right. So to move the s squared to the left, I'm going to have to divide by an s squared. And I'm going to divide by an s squared. Okay. Now, to move the dt over to the right side, I'm going to have to multiply by a dt, multiply by a dt. Okay, so what cancels out here? I noticed that dt's divided by dt's will go away. And s squared divided by s squared will go away as well. Okay, so what we have here is we have an invisible 1 over s squared ds is equal to an invisible 1 over t cubed dt. All right. So that's your first step. We separate. Okay. So we separate it. Okay. Next step is to integrate. Now, here's what I do want to say. If you fail to do the separate step, you will lose all of the points possible for this problem. Okay, on the AP exam, you have to know how to separate. So you can't know how to integrate but not know how to separate, right? So you have to get through this first hurdle. And I'll show you guys some AP examples, okay? So we separated. Now what we're going to do is we're going to integrate. Okay? So we're going to go ahead and integrate both sides, okay? So it's exactly that. Here we go. Let's use this color. Okay, the integral, I'll start off on the right-hand side because it's easier. The integral of x is just x squared over 2, okay? The integral of 1 over y, remember, that is the natural log of the absolute value of y. Okay, you can't use the power rule there. Okay, and since these have no bounds, there's a plus c, and you technically write it on both sides of the equation, but really, all you need is just 1. Okay, and generally you put it on the right-hand side here. Okay, So go ahead and do part 2. Integrate it, press play when you're ready. Okay, so here the integral of g is just g squared over 2 equals t squared over 2 plus your c. Pretty easy. All right. Now the last one here, go ahead and try. Now this one here, 1 over s squared is the same thing as s to the negative 2. Rewriting it is a little bit easier on the eyes. Okay. So once you rewrite it with the negative exponent, you'll end up getting s to the negative 1 over negative 1. Because remember, you add it by 1 and you divide it by the new power. So this will be t to the negative 2 over negative 2. And don't forget your plus c. Okay, so there's your second step right there. So we separated, then we integrated. Okay, we separated, then we integrated. Okay, third step. Find c. Okay, so they tend to give you a condition. Okay, they give you a point. Now sometimes the point is written like f of 2 equals 0, but just know that that's the same thing as 2 comma 0. Okay, they might write this as g of 0 is equal to 4, but really that's just 0 comma 4 and so forth. Okay, so just keep that in mind. I'll show you how it can look a little bit weird on the exam, but basically what we're going to do here is we're going to plug in our x coordinate and our y coordinate. Okay, so here, why did I pick y and 2 and 0? Did I pick the wrong point? Hang on. Why did I pick 0, 2 and 0? Hold on. I think I made a mistake. Okay, whoops. Good thing I checked this. All right, let's do 0 and 2. Okay. Actually, let's do the second example first. That's not confusing at all. Okay, so here instead of x and y, we have t and g. Okay, since g is at the top, that's like your y coordinate. Okay, and over here, this is really just t and s. Okay, so you follow the same order. So when I plug in 0 for t and 4 for g, I end up getting 4 squared over 2 is equal to 0 squared over 2 plus c. When you plug in your condition, you're allowed to find c. Okay? This comes out to c equals, because 0 squared over 2 is just 0. 4 squared is 16. Divided by 2 is 8. So we found out what c is, okay? So what you do now is you plug it back into that plus c. So your new equation is g squared over 2 is equal to t squared over 2 plus 8. All right. Go ahead and try it on this example here, the first example. Press play when you're ready. Okay, so when you plug it in, you should get the natural log of 2. There's no need for the absolute values because 2 is positive. Equals 0 squared over 2 plus c. Okay, 0 squared over 2 is just 0, so that means that c is equal to a natural log of 2. Okay, c can come out really simple or really complex, but it doesn't matter. Okay, it's still a lot easier. So here we go. Natural log of y is equal to x squared over 2 plus the natural log of 2. We just plugged in what c is equal to. Okay? Okay. Now, this last one here it's probably best if you rewrite it. So if we rewrite the negative exponents, s to the negative 1 over negative 1 is the same thing as negative 1 over s to the first power. And this is the same thing as negative 1 over 2t squared. Okay, if you're not sure how I got that, text me. All right, so we have the conditions that t is 1 and s is 1. So when I plug that in, I end up getting negative 1 over 1 equals negative 1 over 2 times 1 squared plus c. Okay, if I clean that up, I get negative 1 equals negative 1 half plus c. And if I go ahead and I add 1 half to the other side, c comes out to negative 1 half if you do your math. Okay, so I'm actually going to go ahead and, actually, you know what? I won't erase it. Okay, so our equation is negative 1 over s is equal to negative 1. Hang on. I'll make it even easier. Actually, you know what? I think that's what you guys would do. I'm trying to think what you guys would do, or the most of you guys would do. So I'm going to stick with the equation that already has the exponents fixed, okay? So here c came out to negative 1 half, so I'm going to put negative 1 half in there, okay? Once again, we found out what c was, so we plugged it back into c, or I should put it here. Okay, so again, I'll mark it just so we can see we separated, then we integrated, then we found c. We separated, we integrated, then we found c. We separated, we integrated, then we found c. Okay, the last part is the fun part. Isolating, okay? Isolating, in other words, you're solving for the variable, okay? So you're looking at the left-hand side. In this case, I have to solve for y. In the middle here, I have to solve for g. And over here, I have to solve for s, okay? And this is where you can easily get it right, okay? And I say easily very loosely here. So here we go. We're going to start off with this one. All right. So to solve for y, I need to get rid of natural log. To get rid of natural log, the inverse is a base of e. And then what I do to one side, I raise it to the other. Okay. So here, y will equal e to the x squared over 2 plus the natural log of 2. All upstairs. Okay, and you leave it alone. And that's it. All right. Go ahead and solve for g here. Press play whenever you're ready. Now, some of you, after solving it, you simplified along the way. And I'm going to show you a very neat trick to make sure that you have better chances of getting it right. Okay, so to get g squared over 2, to get g by itself here, I would first multiply by 2. So I'm going to go ahead and multiply by 2, multiply by 2. That causes these 2's to cancel out. G squared will equal, I am going to leave everything the same. Do not simplify it. Okay, I know it's very tempting to want to distribute that too. Okay, to get rid of a square, I would have to square root. So g is equal to, don't forget square root is a plus or minus. Everything else stays the same. Don't clean it up. And I'll comment on that very quickly. It's a super messy answer, but nobody cares because you got the job done. Now, the only thing you got to consider here is that plus or minus, okay? You actually have to pick whether it's a plus or a minus. And that's going to be based on the point that they give you. So here, this says that G will either come out positive or negative, right? So what did G come out to on our initial point? G came out positive, so we are going to keep just the positive. Now, if G in the initial condition, the point, was negative, then you would end up with the negative root. And then that's it. Okay? Now over here, we'll do this last part together. So here we have to solve for s. Okay? So to get s by itself, first I have to multiply by s to kind of bring it back up. That causes the s's on the left to cancel out. And I'm left with negative 1 is equal to all that times s. Don't simplify anything, okay? To get s by itself, I would have to divide by this giant quantity. And what I do to one side, I do to the other. Now I'm showing the steps here, and I'll show you guys shortcuts on where you can cut corners later. Technically, you don't have to show this step, but I want to show you where the logic is. So s comes out to negative 1 all over negative 1 over 2t squared minus 1/2. Not the cleanest answer, but you got the job done 3 different times. Okay. So we'll talk about it later in the AP prep, but the general rule is you don't get extra points for simplifying. So why do it, right? The AP exam is designed to assess you on your calculus, not necessarily your algebra, okay? But here's the downside. If you decide to simplify incorrectly, it can be held against you. So keep it as bare as possible. For instance, like I didn't distribute this 2 over, even though I really wanted to, because in the case that I make a mistake, I actually lose the points that I earned, right? So anyways, there you have it. We separated first, then we integrated, then we found C, and then we isolated. Separate, integrate, find C, isolate. Sci-fi. Oh, there we go. Now you guys will never forget. Sci-fi. Separate, integrate, find C, isolate. All right? And that's it. So here's another example. Go ahead and write it down. Press play whenever you're ready. What I do want you to do is go ahead and change this to y of 0 is equal to negative 2. Okay? All right. So here's an opportunity for you guys to practice. Okay? Go ahead and press play whenever you're ready. So remember, sci-fi. Separate, integrate, find C, isolate. Go as far as you guys can. If you get stuck, press play. If you're done, press play as well. Okay, so if you separate it correctly, you should get y squared dy is equal to x squared dx. If you showed the steps, that's perfectly fine, but really you don't need to. So we separate it. And then we integrate. That's y cubed over 3 is equal to x cubed over 3 plus c. Okay, so we separated, we integrated. Now we have to find c. So they gave us a condition here. y of 0 is equal to negative 2. So inside, that should represent the x coordinate, and this should represent the y coordinate. So y of 0 equals negative 2 is like 0 comma negative 2. Okay? So when you plug that in, you get negative 2 cubed over 3 is equal to 0 cubed over 3 plus c. Okay? This comes out to negative 8 over 3 is equal to c. Okay? Now that we have our c, we're going to plug it back in. So that's y cubed over 3 is equal to x cubed over 3 minus 8/3. That's our c value here, okay? So we separated, we integrated, we found c, SIF, and then now we isolate. So we got to get y by itself. So we're going to first multiply by 3. So we then get 3 times the quantity of x cubed over 3 minus 8/3. Remember that you should not simplify here, okay? To get rid of cubed, we're going to cube root. Okay, so y will equal the cube root of 3 times x cubed over 3 minus 8/3. And that's it. Okay? Actually, you know what? Shoot. I try to make up a different scenario on the spot, but it doesn't work. So let me just go back and stick with y of 0 is equal to 2. Don't erase everything. It doesn't change much. So that 2 should be a positive here. So that's just a positive 8/3. So that's just positive 8/3 here. It doesn't change much. That would be a little bit more accurate. Now with cube roots, there is no plus or minus. That's not how cube roots work, okay? Because it's an odd degree there. But there you have it. We separated, we integrated, we found our c, and then we isolated. Hopefully you got that practice in. Okay? All right, here's the last one. This is a free response question. Okay? Almost always will you get this question on FRQ number 6. Okay? So there are two things I want you to do. I want you to sketch the slope field, and then I want you to find the particular solution with this initial condition, okay? So go as far as you can, and then we'll double check these. Okay, so with the slope fields, there are 8 points. Kind of hard to see, but there's the 8 right there, okay? So what we're going to do is we're going to have to draw slope fields. So I'll start off on the left at negative 2 comma 0. If I plug that in, I'll end up getting negative 1/2. So something like that. Okay, if I plug in negative 1, 0, I'll get negative 1, which is steeper in the negatives. Okay, so notice how it's more vertical than the last one. Negative 1 comma 1 should come out to negative 2, so that should be even steeper than that. And negative 1 comma negative 1, that should come out to 0. So completely horizontal. Okay, so 1 comma 1, and you don't need to know, you don't need to go in any specific order here, okay? 1 comma 1 is going to come out to 2, so it'll be vertical upwards and steep. 1 comma 0 will give you 1, so less steep. And 2 comma 0 should give you 1/2, so that should be more shallow, more horizontal than the previous one. and 1, -1 should give you 0. So that's what you should have gotten there. Okay? Easy points. And I'll go over the point system when we get into the prep. Okay, here's where I want the majority of the focus on, right? So you have a separable differential equation. Okay. First step is to separate. So I'm actually going to show the step here because people tend to write it incorrectly. Since I want y's on the left, I have to divide by 1 plus y. And since I need to move the dx over, I need to multiply by dx. Okay. That causes my dx's to cancel out on the left and the 1 plus y to cancel out on the right. I'm left with 1 over 1 plus y dy is equal to 1 over x dx. Okay, we separate it. Then we integrate. The integral of 1 over x is just the natural log of the absolute value of x. Actually, I'll do a cursive one. The natural log of the absolute value of x plus the c. Now here there is u substitution involved, but since this is a simple linear, it's really no need to do it. So this comes out to the natural log of the absolute value. Hang on. The natural log of the absolute value of 1 plus y. Okay? If you're not sure how I got that, please do text me, all right? So we separate it, we integrate it. We're going to have to find c next. So the point that they gave us was -1 comma 1. So when I plug that in, I should get the natural log of 2 is equal to the natural log of the absolute value of -1 plus c. The natural log of the absolute value of -1 is the natural log of +1 plus c. And there's only one value that you guys need to remember with natural logs, and that the natural log of 1 comes out to 0. Okay, the natural log of 1 comes out to 0. So c is equal to the natural log of 2. All right, so we separated, we integrated, we were able to find c. Let's plug that guy back in. Okay, so here we have the natural log of 2. Sorry, the natural log of the absolute value of 1 plus y is equal to the natural log of x plus the natural log of 2. Okay, not the cleanest answer. Okay, so we separated, we integrated, we were able to find c. Last step is to solve for y, right? So here we go. To get y by itself, we need to get rid of the natural log here. So the inverse of natural log is e. Okay, so that cancels this out. Now over here, leave it, all right? Because simplifying doesn't do anything. The only reason why I simplified over here is I'm trying to get y by itself. So 1 plus y is equal to e to the natural log of the absolute value of x plus the natural log of 2. Okay? And to get y by itself, I'm going to bump that -1 over. So e to the natural log of the absolute value of x plus the natural log of 2 minus 1. Messy answer, but we got the job done. Okay, hopefully you got that too. Okay, on the AP exam, it's out of 9 points for each FRQ, but generally my students score either 8 or 9 points on this problem, okay, on average, which is way higher than the global average. So follow my steps. You'll get the hang of it, and we should be able to get there, okay? Remember, separate, integrate, find, see, isolate. Sci-fi. I'm going to make that stick. Anyways, that's it.